All right, now that I've gone through and helped and looked it over everybody's lab, I want to get on to the calculation part of the peanut. What we're doing is we're going to calculate the energy, and this is the heat energy of what the calorimeter captured while we were heating up, and that's what the data probe recorded. So we have heat energy. Heat energy is going to equal the mass of the water times the specific gravity of water, which is, if in your chart, is 4.2 kilojoules per milliliter of water. So we're going to do specific heat of water, specific heat, and that's going to be multiplied times the change in temperature. Now we initially started, you'll see temperature initial and temperature final. For my experiment, I've got 14.8. So I'm going to say, in the formula, we're going to say that's the change in the temperature in C of that. So for me, I've got the mass of the water was 50 grams or milliliters multiplied times 4.2, and that's joules per grain of degree Celsius. And that's going to be, that's gram actually. And that's going to be multiplied times the change, which was 14.8 degrees centigrade from the time that we initial to the final of this. So that's going to be 14.8 degrees. Now that's going to equal roughly 393 joules of energy that we released from that peanut burning over that 8-minute period that we data recorded. Now what I want to get into is we're going to convert the 30.93 joules to joules per gram of, and that's the way things are listed in some of the packages. So we're going to now, can anybody tell me what a joule per gram means? Yeah, you're close. It's a unit of grains per energy per gram, which is kind of a unit that will allow you to take different, as we did here, a peanut, you could take a marshmallow, you may also be able to use a popcorn, you can also use a ho-ho, and find out, or corn, popcorn, or any other thing, and they're listed. This is how we get the energy in a drink or energy in a nutrition bar. So what we're going to do is I'm going to convert the joules to grams, since we only had a half a gram of a peanut. The peanut only weighed half a gram, so I'm going to basically say this is going to be divided by 0.5 grams. Does anybody know why I'm dividing this by 0.5? Because the peanut was only half a gram, not a full gram. So that's going to tell us that our unit is going to be per gram. A peanut has roughly, and our unit is 61,800.4 joules per gram of a peanut that we calculated. Now, does anybody know what the rated peanut output should be? Joules per grams of energy. It's close. It's roughly 6370 joules per grain. That's the average of a peanut. Now that changes on the type of peanut, the density, but this is pretty much the given known average for the units. Now I'm going to come around. I'm going to make sure and check all your units, and your calculations are pretty good. Is there any other questions before we continue? Okay.